And if you're seeing this on your Environment One Duplex Protect Plus panel, you're going to have to hook up a buck boost transformer to bring the indicated pump voltage there from what we have here, 206 volt, up to the 240 volt range. I'm going to show this video how to hook up a buck boost transformer. We'll be installing this Jefferson Electric 0.75 kVA. When you buy your 0.75 kVA Jefferson Electric transformer, you're going to get a schematic. Here's a picture of what the schematic looks like, and for the point of what we need to do for the Environment One station, we're going to be using diagram number 4. So for most people, you should be able to use that and wire it up. And then for people like myself, we're going to have a simplified schematic to make hookup a bit easier to follow. All right, this schematic here kind of spells out the directions for people who are a little less familiar with hooking up a buck boost transformer. So when hooking up a buck boost transformer, you can pause this part of the video. At the end of the video, I'm also going to leave the schematic up for a little bit longer. And if I'm able to, I'll also, up in the description area, have a link where you can download these instructions. In the meantime, we're going to try and wire this up real time. The first step we're going to do is take the low voltage input that was one of the legs of our 208, tied to the H1, and then the wire leaving this bundle is going to head back to the alarm panel, and it'll be the first step in getting our voltage up from the 208 to the 240 volt feed. All right, this will be the meat and potatoes of the video here. This is what everyone who's watching this video wants to see, how to wire up this buck boost transformer. So as we said before, you can pause or download the schematic on the right here, but we're taking you and trying to run this through real time. We're going to start. We've got the supply wire here, which is the low voltage. We established that's the 208 volt, or in this case the 206. And we're going to take the ground lug there, tied in together to that ground, and this neutral wire, we're going to be the white wire here, we're going to be connecting that on through so it runs over to the alarm panel. And then we'll be landing the black and red wires, which are represented on our schematic here, is LV1 and LV2 to the appropriate terminals. Give me a minute to get set up here as we run through that. So here we are. We're going to take the schematic. As you can see, the grounds are connected already. We've got the neutral passing straight through. I'm going to start right at the beginning, this from left to right. I'm going to take the low voltage red wire here and connect that to H1 of the buck boost transformer, and the HV1, which is basically just the wire outputting to the EOne alarm panel. So we've got the input voltage there, we've got H1, and we'll grab the other wire that's going to be connected to the EOne alarm panel. That gets wrapped up. You'll see the next step that we have here. So what you see the next step is H2, H3. It's happening only internally. We'll grab H2 and H3 of the buck boost transformer. Grab a smaller wire nut, connect those together. See, as that's getting terminated, we'll come back over here. And this is a bundle of 3 wires. It's going to be the LV1, which is the black low voltage input now. It's going to be internally X1 and H4. So the 3 wires is the black wire, the black power supply, which is the low voltage, internally H4, X1, all 3 of these getting tied together. All right, great. Last 2 connections we have, just internally, starting with X2, X3. We're going to come over here. These are 2 larger lugs or wires there. We're taking X2, X3, tying them together internally. And then getting ready for the last, which is the output of the high voltage of the second leg. And we're going to take the black input lead, or output lead, I apologize. The black output lead going to the EOne panel and connecting that to X4. All right, we're back to the schematic. Now the part in the red The bottom's the critical part. Since we're stepping up the voltage, you can have one leg that reads higher. The 120 volt control breaker, we want to keep it in that 120 volt range, from 108 volts to 132 volts. If we use the high leg there, we can be well beyond that, and upwards of 150 volts. We want to keep that off the control circuit in the panel here. So let's verify what we've got going on. All right, here's a trick for managing these dead front cover lays. Grab a long screwdriver and make use of the cut through the breakers there up into the corner of the panel, and it'll at least keep it up and out of the way so we can verify our voltage now. I'm going to grab our meter and verify what our voltage is. We had 206 before, and from neutral, yep, there we go, 118 volts now. So we're well within the limits on the control circuit from the bottom of that breaker. And now we'll try to verify our voltage on the input there. And 233, so there we go. Up from the 206 to 233, well within the limit and spec, what we need here. So we've seen before, when we're in the trouble light and the voltage was too low, let's see what a happy panel looks like. Here we go. All set. It's reading the 233, 232 or so, 233 voltage. We've got a happy panel being powered with a buck boost transformer, 0.75 kVA.